Action order. What does a rate order of 0 mean? 10 points. Yeah, if you have a rate order of 0, what does that mean?
Something like they can't change or something. Something like. Oh.
Yeah, there's the
Constant.
Yeah.
Concentration.
Oh yeah, the concentration is
Right, the concentration does not change the rate. So regardless of what concentration you change, you get 0 rate change. That's why it's 0, right? And what does a rate order of 1 mean?
I only remember the rate of 0.
It increases the rate of production.
It's directly. It's a direct relationship. So if you increase the concentration by 1, the rate will increase by 1. If you increase concentration by 2, the rate will increase by 2. Does everybody see that? So basically it's a 1-to-1 relationship. And then rate order of 2 is a squared. Make sense? So if you double the concentration, you square that, so it's 4 times as fast. Makes sense? Pretty simple. So as the bell work, we're going over your homework. We're determining the reaction orders. So we're following these 5 steps. And step 1 is to write the rate equations for trials 1 and trial 2. And that's what they want us to do. They say determine M by comparing trials 1 and trial 2, which is exactly what we're doing right here. So we're just following this pattern. So much of sports is, can you follow the pattern the coach is telling you to do? And you have to do it over and over again. You have to practice these 5 steps over and over again until it becomes like a habit. Now, in sports, how many times you got to do it for it to be a habit? Raise your hand. No, more than that. Yeah, it's more than 10,000. Muscle memory takes how many reps? It's around 40,000. 40,000 reps, yeah. All right, so let's go ahead and do step. Eliza, I've already seen your library. If you look at the example right here, it says rate 2 equals 4 of rate 1. Well, how did they get that? Well, if you take 4 times the first rate, you will get the rate 2. So it's 4 times the first rate. That's why they're saying 4 of 1. Does everybody see where it says 4 of 1? 4 times the first rate equals the second rate. Now, on the trial over here, Colin, I need you to sit in your chair. If you look at the example here, we have trial 1. If you divide the rate here, this is a smaller number, by the second rate, you get 0.5.
But why is it 1.4 instead of 1.2?
Because they're giving you the rates. These are the rates in the problem. It's a different problem. I'm comparing the example to the problem we're doing. Okay? So the problem here has got different rates. So this rate in this example here is 7.2 times 10 to the negative 3. So if you divide that by 1.4, you get 0.5. So if you take 0.5 times the 1.4, you get the 7 times 10 to the negative 3. Right, so you get 0.5, rate 2 equals rate 1. So these two are equal. There's an equal sign there. The math has to show that they're equal because there's an equal sign, just like you're showing right here. Any question on that? 1.4 times 10 to the negative 2 divided by 7.2 times 10 to the negative 3, and you get 2. So then 2 of your original rate right here is going to give you 1.4. So you can say rate 2 equals 2 of rate 1. This is rate 1. You're multiplying it 2. They're the same thing. Now, no, if 7.2 is your first rate, right? If you multiply it times 2, you get your original or your second rate, the 1.4 times 10 to the negative 2. So what we're trying to do is to figure out how we can make these equal. You can do it either way. You can do 0.5 times rate 2 equals rate 1, or you can do rate 2 equals 2 of rate 1. There's more than one way to do this. So some people like to try it different ways. I'm just trying to show you the goal is to get them equal. Right here, you could have said in the example, you could have said like 4 of rate 1, and you could have done like 1/4. The first, that's the pattern they're choosing to follow. You can do it either way. I mean, this is equal. It's just if you like fractions, that's what you're gonna have to deal with. When you're dealing with fractions in like exponent value, it becomes a little tricky. Yeah, so we'll stick with the whole numbers here. All right. Create this formula, rate 2 equals 2 of rate 1. So we just take our rate 2, which is right here. Then we take 2 of rate 1. So we take our rate 1, we place it there. Substitute the equations from step 4 into the equations of step 3 and simplify. So you're getting rid of all of the B2s. So A2 is going to be 2A1. So up here we see A2, it's going to be 2A1. And then it's going to say B2 equals B1. So you put where it says a B2, you're going to put B1. So you're getting rid of the 2's. And then we're going to simplify, just like you see right here, we're getting rid of the 2's. Cross out what's the same here, same there. A1 crosses out, B1 crosses out. So this crosses out, N crosses out. So we're ending up left with 2, N equals 2. And N equals 1. So one of the M's does not cross out, as you can see here. So I missed one of those. Like if you're taking creatine, you ever heard of creatine? Yeah, so if you're taking creatine and you take, 1 cup per workout, and you got no effect, and you take 2 cups per workout, you got no effect, right? That would be a 0 order. There's concentration has changed, but the rate of your muscle growth did not help at all. Everybody understand that? That's 0 order. Now, let's say that you had a medical disability and they're trying to figure out a way to help you, so they give you a little bit of a steroid. They give steroids too to help you with like poison ivy. So let's say they give you a little steroid, they give you 1 dose, it has a 1 level effect increasing the rate of, let's say, the poison ivy going away, or the effect of you being able to exercise a little bit better. So when it's a 1-to-1 ratio, the concentration of 1 increases the rate by 1. That's called a rate order of 1, right? Now, most people don't like that. They want like the Tour de France. What's the guy's name? Won the Tour de France? The Lance Armstrong. They want the Lance Armstrong effect, where you take 1 thing and you get 8 times the effect. So if you doubled the concentration, you had 8 times the effect. That'd be 3rd order, because 2 cubed is 8. Right? People want that. They want to have those excellent rate increases, because that makes them faster, and fast wins. Y'all want to win, right? You understand that? Now,
replacement or double replacement, defining characteristic of combustion and single replacement reactions is that it always involves the transfer of electrons from one atom to another, as do many synthesis and decomposition reactions. For example, the synthesis reaction in which sodium and chlorine react to form the ionic compound sodium chloride.
Actions always have a charge change taking place. Like this is an element. All elements have 0 charge. That goes back to the beginning of the year. This element has 0 charge. And you can see that it is doing what? Is it gaining or losing an electron? It's actually gaining an electron. Very good, because chlorine has 7 and wants to get to 8. So when you gain an electron, what's that considered to be? Is it considered to be oxidation or reduction? Yeah, gain electrons reduced. Very good. So that's a reduction. So here we have bromine that's 1 negative and it becomes 0 charged. So this is a, it's lost an electron. So here it's 1 negative, it's got 8 electrons around it, and it goes to bromine, 0 charge as an element. So you have to remember that redox is all about changing in charge. That is, when you look at the actual substance, has it changed its charge? In this situation it has. It's gone from 0 to 1 negative. Also the book on page 681 shows you sodium going from 0 charged to 1 positive, and it's losing an electron. So the loss takes place in the products. You can see that this is an oxidation, lose electrons oxidize because it takes place in the products. The reduction, gain electron reduced, is occurring in the reactants. You're gaining those and then it's reduced.
Well, in a zero situation reacts with bromine iron from a situation of, I don't know, in which it
Bromine.
shows on figure
Or bromide.
bromine, in which it shows figure 19.2. Complete chemical equation 2 kBr. All that.
Very good.
Next iron equation. Note the colon takes electron from bromine iron to become right iron with the 2 bromine ions, loses electrons that 2 how you say it again?
Bromine.
Bromine atom from a covalent which other to product in form of condoms by sharing of electrons is also oxidative
Reduction.
reduction reaction.
What does it take to have muscle memory? 85? No.
158.
More than that?
3,000.
More than that? Raise your hand. Diana? Raise your hand.
6,000.
More than that?
10,000.
Raise your hand.
10,000.
Because if you're correct, I'm going to give you points. Vance? No.
11,000.
No.
12,000.
More.
13,000.
More. More.
15,000.
More. More.
100,000.
More.
25,000.
It's around 40,000. It takes 40,000 reps. So if you are running a lot, you will start to just do things by habit. That's called a habit. You do it. Now, how many days? How many days in a row does it take to form a habit? Doing something in a row.
45.
They say around 21. 3 weeks, 21 days. So if you're kind of like smoking, in order to quit smoking, it takes about 21 days in a row to say I've quit smoking. No. If you haven't done it in 21 days, you can say that you've effectively, stopped that habit. Now, up here, with that said, we're looking at the steps that we want you to check your results with from your homework. So we're following these steps right here that are in the example. And we have step 1. It says to write down the rate for the first one and the rate for the second one. So that's what we do. We have K, which is the rate constant. We have A, which is the concentration. And then we have M, which is the order. So M is the order, N is the order. These are the 2 concentrations. That's what comes from the book. So we write that down for both of them. The pattern is repeated for the second rate because you change the concentration. A, trial 1, trial 2, the concentrations are different. Now, step 2, that's when you're going to compare the rates. Now, you can divide, like you have here, 1.4 to the negative 2 by 7.2 to the negative 3, and you get 2. So they've just taken the second value, that is the second rate, put it in the numerator, and the first rate as the denominator. This is the first rate, and they get 2. So basically you're saying that it takes 2 of rate 1 to equal rate 2. 2 of rate 1 equals rate 2. That's the equal sign right there. I just want to know, can the rates be equal? Yes, they can. We can make them equal by doubling it. 2 of this. Now we just substitute. We take our rate 1 and we put it here. See how we got our rate 1 there? And we take our rate 2 and we're going to put it right there. That's what we have right here. So rate 2 goes right here. That's what it says. I'm just substituting. Then step 4, we're looking at the concentration. It takes 2 of B1 to make a B2. That's what you see right here. It takes 2, because it's 0.3 to 0.6, and that's B. You see the B right there. It takes 2 of the B1 to make the B2. Now the last thing you need to understand about this, and where it gets a little bit complicated, is associated with your concentration, right? This is the concentration. Concentrations always have an order to them. They left this off in the example. So the example here, they didn't put an M there, and they should have, because every concentration has an order. That's why you see this concentration here with an order. This does not, because this is not a concentration, it's a rate. You see the rate right there? So that's a rate, this is a concentration. That's how you solve for M and M. M actually equals 1 there, so I put N. That's a typo error on my part. It should be M. I'm sorry, it happens. But just be aware that the book or the notes can make mistakes as well and leave things off. But every concentration requires an order, just like you see here. This right here is a concentration. It requires an order. So keep that in mind.
Each oxygen atom. Two magnesium atoms become magnesium ions, Mg2+, and the 2 oxygen atoms become oxide ions, O0 negative. And the reaction is with electrons that transfer from one atom to another is called an oxidation-reduction reaction, which is also called redox reaction.
So on the board over here it says, how do you know a reaction is redox? Raise your hand if you can tell me. How do you know a reaction is redox? Vance? How do you know a reaction is redox?
Whenever it's redox, it's very different.
Now if you look up here, if you remember the beginning of the year, gold is an element, right? It's an element because it has 0 charge. Very few elements are found naturally in nature. But this is an example up here of chlorine. It has 0 charge. Now if chlorine gains an electron, that's called a reduction. Gain electrons reduced. Now if bromine loses an electron, that's called oxidation. Lose electrons oxidize. So if the charge changes, everybody say there's a charge change. When there's a charge change, it's redox. Specifically with the element. It has to be a charge change on an element. So the chlorine went from 0 to -1. That is redox, a charge change on the element. No, no, no.
It's below 1,000.
It's below 50.
What? 40.
40,000 reps. Right, but that's not always the case. B2 equals 2 of B1. So you look right here, B1 is 0.3, 2 times 3 is 6. But you have to remember up here, concentration always has a rate associated with it. Does everybody see that? Concentration has a rate. This is a concentration, it must have a rate. So when you come down here, the concentration must have a rate associated with it. Now this right here is your actual rate. Remember we said over here it takes 2 of these to get this rate. So this is a rate. This number here is associated with the rate. This is a rate. This is a concentration. Does everybody see the difference? We're looking at concentration here. We looked at rate up here.
Where did you get the 7.2?
It was given in the problem here. That's why there's no M above this 2 and there's an M above this 2. Because this is a concentration. This is a rate change. That's why you don't, everything crosses out but the M. And then we solve for the M, we divide by itself, and it equals 1. So the rate order for this problem is 1, or first order.
Ionic compound sodium chloride. An electron from each of 2 sodium atoms is transferred to the Cl2 molecule to form 2 Cl negative ions. Do I go down here?
The question is, how do you know a reaction is redox? Raise your hand. 20 points. Well, if I tell you that, then I can't give you 20 points. Raise your hand if you know. How do you know a redox? How do you know a reaction is redox? No. No. No.
Hold on, don't say it. Don't say it. Don't say it. Not yet, not yet.
What was the question again?
How do you know a reaction is redox?
It's an oxidation-reduction reaction.
Now, in the beginning of the year, we talked about the mole, and how did we determine the mole? What was used to count the mole? Raise your hand. What was used to count the mole?
Electrons?
Electrons, right? So we're talking about electrons up here with redox. Gain electrons reduced. Lose electrons oxidized. Now, elements, what charge do they have? Raise your hand. 10 points.
Positive.
No. No.
Neutral.
All elements are neutral. They have 0 charge, like gold. Periodic table, every element on the periodic table has 0 charge.
Do I get points for that?
Yes.
Oh, wait,
Now
wait.
up here.
I have the one for the 25.
Okay, go ahead.
It's when a reaction where electrons are transferred from one atom to another. Which is
Very good.
An oxidation-reduction reaction is also called a redox reaction.
Electrons being transferred. So up here you have
So I get 20 points?
a 0. Does everybody see the 0? On the actual element. And it changes to -1. Anytime you see an element change its charge, that is electrons moving, that is a redox. Now, why do we care about this? Well, your automobile, when it rusts, raise your hand if you want your car to rust in the future. Jake, if you want your car to rust. Help of memory, how many times does a rep have to occur?
100,000.
Less than that.
23.
More than that. 40,000. 40. We talked about at the beginning of the year.
No, that's
40,000. It's at 40,000.
Yeah, it's on video.
You'll see that. Hey, drop a comment below and see if you said 40,000.
40,000. Now that's a lot of reps. Now it's been said that Tiger Woods hits around 1,000 golf balls a day because of that.
Yeah, he's crap.
Okay, well, he's better than me. 31 days for habit.
I said 21.
23. You think Noah?
What? It's 23.
I'd say 23.
100 days.
100 days.
21.
It's around 23. 23 days. 23 to 21. Between what is the difference between a habit and a memory?
Habit means you have to do it. Habit, you do it. You don't have to think about it. You just do it.
A memory just occurs like if you're good at soccer and there's a specific play, you can do it without even thinking about it. Like if you're playing golf, you can get up there, you have muscle memory, you can do the swing without even thinking about it. You just walk up and you swing and you hit the ball and it goes straight down the fairway. Now a habit is something that you've kind of gotten used to doing, but it's not necessarily a memory, a muscle memory. There's a big difference between the two. You still have to think of kind of what you're doing with the habit, but it just becomes, I guess you would say, part of your lifestyle. A habit is kind of part of your lifestyle, like smoking. Smoking is a habit. Smoking is not a muscle memory, right? Like, let's say chewing your nails. That's a habit, right? It's not a muscle memory, it's just a habit. In order to break that, you'd have to stop doing that. You need to practice this in order for it to kind of be in your memory.
40,000.
40,000.
40,000.
No, you don't need to do it that many times, but how many times did you have to practice this?
10.
5.
It's going to vary per student. But what I do, I like leave it blank, look at the example, go back and see if I can do it. And I would do that at least 3 times, and then I would repeat it again until I could do it without looking at the answers. So if it might take you let's say 7 times to do it. At the most, I would say 21. You should be able to do this in less than 21 times in order for it to be in your brain as a memory. Now, the only reason why I'm telling you that, when you get to college, you cannot wait till the end to practice things. If you wait till the end to practice, you're not going to have enough time. This is going to take a little bit of repetition to get this in your memory. And you're going to want to remember that if you're trying to go into a career, it's going to pay you a lot of money. Let's say like being a doctor or a pharmacist or an electrician or an engineer. Those fields, they want to know if you're willing to pay attention to what you're doing. Because if you're not going to pay attention, people get hurt and then people get sued. Right? And that's not good.
It's shortened to LEOGR.
All right, so what does redox, or how do you know a redox reaction has occurred? What does redox mean? Electrons used to calculate the mole, like Josh said. Then how do you know that a reaction is redox? Now, if we remember on the periodic table, what's the charge of the elements in the periodic table, Noah? What's the charge of the elements in the periodic table?
Oxygen.
No, there's 0. They have 0 charge. So like gold has 0 charge. It's an element. Most elements don't exist in their elemental state. Most are ions bound with another substance as a salt. So we have to purify them, and when we purify them, we can make them into elements. That's why it took a long time to get the periodic table together. It's only 156 years old because of that. So chlorine, 0, has 0 charge, and if it gains an electron, it has 1 negative. That's called a reduction. That's part of oxidation, reduction, redox. And then if we have bromine here that has a negative charge, and it loses that electron to 0, that's called gain electrons reduced, and lose electrons oxidized. So it lost that electron, it's oxidized. You see that? So anytime that a element changes its charge, you have redox. Does everybody see there's a charge change up here of the elements? That's how we know it's a redox reaction. Now, raise your hand if you do not care about your car rusting. You want your car to rust? Okay, well, in the future you will, because that means the car could like
Blow up.
not blow up, but get in a wreck easier. Somebody might not be able to, stop, or the rusting underneath of it could cause the axle to maybe break. So rusting is a big issue. A lot of car companies are concerned about it because accidents happen, and if they're blamed, they have to do what's called a recall.
Air, which involves the transfer of electrons. When magnesium reacts with oxygen, as illustrated in figure 19.1, each magnesium atom transfers